Hey everybody, this is Larry. This is day 14 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Today I am here in Buenos Aires. I just got in, so a little bit late. I was going to do an intro with all the flying and stuff. Maybe I'll do that tomorrow or something, or later today, I suppose now. Yeah, I guess that's it. I'm still settling in. I literally just got in like half an hour ago. Everything took so long. So yeah, so let's take a look at today's problem and let's go. Okay, today we have 2536. Increment submatrix used by 1. Okay, so you're given stuff. You get. Sorry, I'm like. I don't know if you could hear it. Let me know in the comments if you could hear it. But unfortunately, I thought I asked for a quiet place, and it's probably way quiet at night. But for the same reason that it's not quiet right now is because there's a schoolyard outside my window, and this is, I guess, prime schooling time. So I don't know. Let me know in the comments if you could hear it. By the way, let's take a look at today's problem. I'm going to watch it a little bit because I actually have not eaten in like, I don't know, 20 hours or something. I mean, other than airplane food, but I don't count that. So yeah. All right, let's go. Okay, so you want to add 1 to some submatrix and then and then return the matrix. I mean, I think, okay, so problems like this, I think initially you have to see what the complexity is if you do it naively, right? Because here, you could obviously just write for loops, then you're very Gucci. But here, it seems like they want a little bit more efficient. We have 500. 500 is 500 by 500. And then you have, was it 1,000? No, 10,000 queries. And this being the situation with the 10,000 queries, right? I mean, I think the idea that I would think about is, the first thing that I would think about is just what would you do if it was one dimension, right? If it was one dimension, then you would have basically, you have the same idea. You basically have an array. You have a left index, right index, and you have to add 1 or something, and you have to do that. And of course, there's something that I do know, which is the difference array, right? So I guess we can do something like that. Right, with 2 dimension, how would that look like? I mean, even if you just do it, if you dissect this into, and I think maybe that's it. I mean, I think I try to think about it to, you don't, or you should not prematurely optimize, right? And I think initially I was like, okay, if we have this idea of difference array, maybe we can do like, okay, you have different corners, stuff like that. And I think you can do it. There's probably a way to do it, but keep it stupid simple, right? Or keep it simple stupid. I forget which one it is. But in any case, just keep it simple. And what I mean by that is that now we just have, instead of doing a difference matrix or something, I don't know, maybe, and I'm sure there's a way to do it, but the way that you might do it may not be a medium. But the way that I'm thinking of is just what we said about the 1D array, right? One dimension array. Just do it 500 times, and that should be good. So I mean the math, and of course you have to do the math. You have 10,000 queries. Each of them you just do a loop of 500 times. That is actually going to be fast enough, and we are happy. And this is an n. That's just a typo. Okay. So then maybe you have now you have the matrix is equal to 0, right, times n for right. Also, here's the part where I spam. If you're curious about my travel, come check out the Instagrams. Yeah, it's in my description or whatever. In any case, okay. So then now we have for the query. What was it again? Okay. So row 1. Well, I just do it. I'm lazy. Man, my stomach is like asking me to eat. So yeah, but yeah, so now we just maybe do something like for x in range of R1 to R2 inclusive, right? And then yeah, C1, you know, and this is just difference array stuff, right? I think it's technically C1 plus 1 because we want to be inclusive, and that's of course if only if C2 plus 1 is less than n, right? So then, I mean, sometimes you could do it with the difference array. You would actually have an outward bounds element to kind of denote the n, depending on how cleanly you want it, right? And then now, after everything is done, we just mix it back up, right? And you know, current is equal to 0, right? Matrix of x of y is how? I guess it's just I guess there are a couple of ways to write it. You could just write it this way as well, right? And then I think we're good. I mean, it looks okay here. I'm too lazy to check it. So hopefully I just didn't make a silly mistake. Or it doesn't time out. All right, 54-day streak here in Buenos Aires, Argentina. Hopefully as the days goes by, I'll say it, you know, I'll pronounce it a little bit better. I am going to go get food. Thanks for watching. Hit the like button, subscribe button, whatever. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye-bye. Nope, that's not the button. Oh, I didn't go over the complexity. I mean, I guess okay, let's go over the complexity real quick. I mean, this is O of Q, or I mean, not O of Q number of queries. For each query, we do O of N, right? So this is going to be Q times N, and then we do an N square at the end. I mean, there's also an N square at the beginning, of course, because you know, that just takes time to initialize. But yeah, I think that's it. That's all I have for this one. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.